Hello, this is Douglas Rumbaugh, and welcome to episode 6 in my introduction to web hosting video series. Now, at this point, we have a fully functioning website, effectively. We are serving our pages over HTTPS. We can go access it via domain name from a web browser. So all is well and good in the world. However, I couldn't in good conscience leave this series without also addressing the concept of a firewall. Firewall is a piece of software which controls effectively what network activity is allowed to come into and go out of your server. Now, unfortunately, as I have mentioned before, I am a programmer, not a systems administrator. And although I may have been able to fake it potentially up to now, here's where it's going to start to fall apart because I don't know a ton about firewalls. However, I do want to at least mention it and show you a little bit about how this works. Bear in mind that what we do here is, I think, possibly adequate, but I am not an expert. So before you go deploying firewalls on important production servers or anything like that, I would definitely have a conversation with somebody who knows a little bit more about what they're doing than me. Disclaimer out of the way, let's take a look at this. So OpenBSD uses PF, or packet filter, for its firewall. Now, PF is a very, very, very sophisticated piece of software. It's configured through a file called pf.conf in etc. And if you use man on pf.conf, you can read at length about all of the functionality and keywords and everything that goes into this. If you are at all interested, I highly suggest that you start here reading through this man page. One of the wonderful things about OpenBSD is that its documentation is phenomenal. The man pages, in fact, there's a httpd.conf man page as well. The man pages provided are amazing, and I highly recommend you take advantage of that if you're running an OpenBSD server like we are here. All the information you could ever need and more about how to use these is very well documented and fairly easy to read as well. PF seems to be largely designed for fairly complicated use cases like a firewall server sitting on a network, or for packet routing, setting up a router and things like that. So we're only going to be scratching the surface. And the approach that I have for my PF firewalls is crude, shall we say. I'm sure that some network administrators are going to look at this thing and cry, but it does seem to get the job done. So, again, your mileage may vary. PF is running by default, so we don't have to enable it or anything like that. And it will load the configuration file by default every time it starts up. So we're going to want to tweak our configuration file, and then we can manually tell it to load the configuration file once we've updated it to verify that it's working. And from then on, every time it boots, it should load our configuration. So no special considerations for RCCTL are needed there. Let's take a look at the default configuration. We're going to be throwing it away and starting over, but let's just take a look at what's in it to begin with here. Now we're going to need root privileges to even look at this file. And here we go. Pretty simple. The default configuration is going to block X11 forwarding, block some output for the port build user. We're not using ports really, so whatever. And yeah, so that's your default configuration that's running right now. It doesn't actually do a whole hell of a lot. Let's throw this away and start over. Now, per usual, whenever you are editing a configuration file, it is generally considered good practice to make a copy of the working file that you have. That way, if we horribly mess something up, we can always revert back to our backup, right? Pretty good practice no matter what configuration file you are updating. When you're going to make significant updates, make a backup copy first. That way you can roll it back. And then from there, we'll just go ahead and edit this thing. And I'm going to nuke everything. Okay, So the way in which PF works is you specify a list of filtering rules, and you can either block a packet or pass the packet. Block means that the connection doesn't go through. Pass means that it does. So we list a bunch of filtering rules, either blocking or passing packets in sequential order. And what PF is going to do is it's going to apply those rules for each packet coming in. And the last rule that it sees that matches the packet we're looking at is what is going to take. It's what's going to actually apply. Unless we specify the quick keyword in our rule, at which point PF will stop filtering when it hits that rule and just apply it. We won't be doing that here. So the very first rule that we apply, or that we state in here, should be the most general one, and then we can apply increasingly specific rules underneath. And then the increasingly specific rules are the ones that are going to match in their specific cases. They'll override the general rule at the top of the file. Now there are two major security stances that you could take when you're setting up a firewall. You can have a default stance of blocking everything and then apply specific rules to allow certain traffic. Or you can do the opposite. You can take a stance of allowing everything and then apply specific rules for blocking the traffic that you don't want. Blocking everything is the safer of the two approaches, especially if you don't know what you're doing, and I certainly don't. So let's start with that. We're going to block everything. And that's quite simply done by just saying block all. That will block all incoming and outgoing traffic by default. Now this, if we simply apply this rule as is, we are going to horribly break everything because there's a lot of processes running on this this server, that require incoming or outgoing traffic. But we can say block all like that, and that can be our starting point. Now actually, we have a couple of options for what we can do when we block. So by default, if I just say block like this, block all, PF is just going to throw the packet away. It's not going to respond at all. If you want to be a little bit kinder to people, you can do a block return all. And when you do this, rather than simply throwing the packet away, PF will respond to the person who sent the packet saying that it was blocked. I'll demonstrate the difference between these things in just a moment using our web page access here, because it makes a pretty significant difference in how the web browser behaves when you try to access and you don't have ports allowed through. One thing we want to do is allow outgoing traffic from the server. If you are particularly security conscious, you can go through here and filter specific things. You can have an idea of what outgoing traffic should be generated from your server, and then you can block stuff that doesn't match that. As some examples of outgoing traffic that we would expect coming out of this, obviously we have our responses to our web requests. That's outgoing traffic that needs to be allowed. We need to allow the outgoing traffic for our SSH connections. We need to allow outgoing traffic for the package management. We need to allow outgoing traffic for NTP, the network time protocol. And there's a variety of other things like that. I'm just going to allow everything outgoing and only filter incoming. So this is perhaps not the most secure approach, but it does work. So we have pass. Remember, block blocks the packet. Pass allows it. So we're going to pass outgoing traffic. INET versus INET 6. This is IPv4. This is IPv6. I'm going to allow both. Although we technically don't have IPv6 networking set up. When we installed it, we skipped that. I'm going to leave this in here just in case. It doesn't hurt. We're going to apply this rule to traffic coming from and going to anywhere. So PF allows you to specify specific network interfaces, which we're going to do for our incoming traffic rules. It allows you to specify specific sources based on IP address and port, specific destinations based on IP address and port, that you can get very, very specific with these rules. The all is just going to blanket. Doesn't matter where the traffic's going to, what port it's going out on, we're going to allow it. Now, keep state is also significant. The specific details of how this works probably aren't super important for right now. If you want, there's a very good description of why stateful Packet filtering is useful in the man page, including discussion of the computational complexity, which I quite appreciated. Effectively, what happens is when a particular packet is allowed in or out through a PF rule, it creates a state record, and then PF keeps track of other packets that are associated with that particular transaction, that particular connection, that particular state, and will default allow everything that's associated with a state that's already allowed, which means that it doesn't have to process the full rules list for everything. Once it identifies that, hey, this is part of that transaction I've already allowed through, it will just allow it through. So keep state is to basically tell it to create state records where necessary for this outgoing traffic, and then we're good. This is particularly nice here because it means we don't have to account for the incoming traffic associated with these outgoing requests, right? So when I run my package manager to do, say, an update, the package manager is going to send a request out, and then a response is going to come back. By doing this using state, the return response from the package management servers are going to be associated with the request that I sent out, and so they'll be allowed through irrespective of what my input rules are, which means in my input rules I don't have to account for the necessary ports to facilitate that happening. At least that's how I understand this to work. I only have gleaned this information from reading the man page and a few other things, so I'm not an expert by any means, and I could be off base on that. I'm not going to claim expertise in the area of firewalls. So that's going to allow our outgoing traffic. We need to allow some incoming traffic as well. Specifically for this case, we're going to need to allow SSH through. We're going to need to allow HTTP traffic and HTTPS traffic. We're going to pass in, and we can actually specify at this point the exact network interface we're dealing with, because all of our incoming traffic is going to be on that VIO0 network interface. If I do an ifconfig, this will show you the network interfaces, right? And our public IP address here is on VIO0. So this is specifically the network interface that all of our external traffic is coming in on. So we can specifically put this as the interface for our incoming traffic, right? So we can say pass incoming traffic on VIO0 proto TCP. This is specifying specifically that it's TCP traffic and not UDP traffic. From anywhere to anywhere on port 22, which is our SSH port, and we'll do keep state here as well. So this line here should allow our SSH traffic through the firewall, which is important because we don't want to get kicked out. Let's go ahead and enable these rules now. PF should already be running. It started by default on OpenBSD, but you can double check it just to be sure if you want. The pfctl command, pfctl, there we go. The pfctl command has flags for turning it on and off pretty easily. So the TAC-E flag is going to enable it. You can see it's already enabled. If for some reason you wanted to disable it, you can use the TAC-D to disable it, and then E will re-enable it. So right now, PF is running. And incidentally, while we're here, we can also check using pfctl to see what the current rules that it's using are. And that would be a sudo pfctl tac-sr. This is going to list the current rule set. And as you can see, these are those default rules from the file that we started with. Now we want to load our new rules, and the way we do that is pfctl tac-f and then specify the rule file. Now we can actually do nf like this, which is going to do a dry run, kind of like n for HTTPD did, where it tests to verify that the file is okay, but it doesn't actually load them. Let's do this first, verify that we haven't made any stupid syntax errors in our configuration file. No word is good word, and now we can just go ahead over here and load those rules. Just like that. Let's verify that our new rules have been loaded. If we do pfctl, we should be able to do an sr, again, to show the rule set. And you can see we have block everything, allow the output stuff out, and pass in on port 22. Now, notice that my website no longer works. This is because we are not allowing HTTP or HTTPS traffic in anymore. The only input traffic that we're allowing is on port 22. So if we want our website to work, we're going to have to actually allow input traffic on port 80 and port, what was it, 443? Yeah, port 443 and port 80, right? These ports need to be open through our firewall for the web browser to work. At this point, though, let me take the opportunity to show you the difference in behavior between a block and a block return. So right now, the configuration file is set up with a block return. And what that means, I'm going to launch a private browsing window just to get around any caching things. When you open and close a private browsing window, it resets your cache. So I get an immediate site can't be reached. Now, if I change this to just do a block instead of a block return, and one of these days, I should just install NeoVim and be done with it. So if I get rid of this return here, and then reload the configuration file, like is that, now it's not going to return an access denied or anything, it's just going to throw away the packet. Which means that if I go to this website, notice that it doesn't immediately present me with an error page. The web browser is dutifully sitting there waiting for a response from the server. And eventually it will time itself out and we'll get that same message. So that's the difference between block and block return. Technically block, I believe, requires fewer processing resources on your end because you don't have to send any responses, or the server doesn't have to send any responses. But I like block return because I feel like this behavior is a little bit rude. So we'll put that block return back in. And now let's get our HTTP and HTTPS working properly. So we're going to have to add new lines for port 80 and for port 443, just like that. And this should be enough to get our web browser traffic working properly. So we'll go ahead and reload the configuration file. And now, if I make my web request, you'll see it works just fine. So we're allowing our traffic in. Now, while we're here, it's probably worthwhile to test to make sure that some other stuff that requires networking is working properly. Because as soon as you start blocking ports, you run the risk of blocking a port that some service on your server is using that you're not aware of. So it's a good idea to run through and verify that some other stuff still works. Notably, one thing that's easy to accidentally break if you start blocking ports willy-nilly is the package manager. So let's do package add tac-u, make sure that still works. And as you can see, it does. So that's good. Just to show you this, you can pretty easily break it if you don't allow UDP output. So let me do that. So if I enforce this to say proto or TCP, like that. So if I'm too specific on that one and I don't allow UDP out, then whenever I reload my configuration, I think I put that in the right order, yep. Like that. Now, when I run package add, you'll see I get this error here saying that it can't find some stuff. So it fails all domain name lookups on these FTP servers. So be careful of that. If you start seeing this error on package add, you can verify that this is in fact a firewall issue by disabling the firewall and then rerunning the command. And as you can see with the firewall disabled, it now works. And so that's a good way of checking to see if the firewall is the thing that's breaking your command. And in the case of packages, the solution is to allow UDP traffic out. So another thing that can very easily be broken with the firewall is NTP, the network time protocol, because that relies on network traffic too. So if you run NTP CTL, you can use this to verify that things are still working. I believe the flags are SA. Yep. And so you'll want to use this and make sure that the clock is synced and that you're able to get some of this stuff. Because if this errors out because you're not allowing network traffic that is required for NTP, then you'll have clock synchronization issues, which are not great to have on a web server, as I'm sure you can imagine. A few other points to mention. We can simplify our, well, arguably simplify. We can make shorter our pf.conf file by taking advantage of macros, which is effectively what pf calls variables. And let me show you what that looks like. Probably a good idea to do this. So notice, for example, here we have the same line repeated 3 times with just a port changed. So as a first simplification, what we can do is we can actually take advantage of what's called a table, which is what the OpenBSD networking stuff calls an array, basically. So if I do this, I use curly braces like this, and inside of these curly braces, I do a comma-separated list of the ports that we want to allow through. I can list multiple ports on one line, and this works for pretty much any of these objects. You can use this for interfaces and IP addresses as well. And now, it should work the same way, but it's 2 fewer lines in the file. Just like that. And if we do a pfctl sr, you can see we still have the same set of pass-in rules here. The pf is going to expand those out into those 3 lines for us, but we have a much nicer looking configuration file. While we're at it, we actually can use names instead of ports for the different services, as long as our services are running on the default ports. So if we take a look at, I believe it's etc services. Yeah. This is a file which lists a large number of network services as well as the port and protocol that's used. So for example, here we can see SSH here runs on 22 TCP and 22 UDP. Which makes me wonder, maybe we should open up 22 UDP as well. I think we're only opening up TCP at the moment. And we can also find, for example, there's NTP, the network time protocol. So, and actually I should point out, you'll notice, for example, that NTP here is working even though I don't explicitly have outgoing NTP traffic, or even though I don't specifically have incoming NTP traffic allowed. And that's because the NTP transfer starts with the server sending a request out, and so that creates a state record, and the response is associated with that state record. So even though I'm blocking port 123, technically, because that response is coming as a result of a packet that started at my server, it gets allowed through anyway because of that stateful packet filtering. So in any case, what we can do is we can actually, rather than saying 22 in our file, we can actually say SSH as long as it's in this etc protocols, and it will work the same. So let's go ahead and take care of that. Rather than 22, we can say SSH. Rather than 80, we can say www. That's the protocol name for HTTP. And then 443 we can replace with HTTPS, like that. And again, if we load this configuration file, and list out our pfctl rules, you can see we get, again, the exact same rule set. It all gets expanded out, but it makes our file a bit more legible. Again, this only works if you're running these services on the default ports. I know there are some people who claim that you should never run services on the default ports because it makes you more vulnerable to basically scripts that run down big blocks of IP addresses and try to hack you over SSH, for example, and they're going to assume that you're running on port 22. So if you're not running on port 22, you can avoid that. That's a decision that you can make on your own as to whether you want to run SSH on the default port or change it. You should, of course, run these guys, HTTP and HTTPS, on the default ports because that's what the web browser is expecting. But anything else, you could technically change the ports if you would like. Let's take a look at some other changes that we can make in here. Now, in addition to this table, we can actually take this and move this to the top of our file using a macro. So what I can do is I can effectively define a variable. Let's call this allowed, or we'll call it TCP ports. Like this. And I'm going to do a UDP ports one as well and allow that SSH on UDP. And so now what I can do is go over here and I can replace this table with $TCP ports like that. And while we're at it, let's define our interface as a variable as well, that VIO0. So I'll call it external interface VIO0 like that. And then we can come down here, replace this with $external int like that. And forgive me, I forgot these guys need to be in quotation marks for this to work properly. And we'll go ahead, duplicate this line for UDP with our UDP ports. So now if you ever wanted to allow UDP traffic through as well, you can just specify the ports that you want UDP connections to be allowed on right there. Let's save and reload this. And as you can see, we now have our new rule set right here, and we should be good to go. Now, as a final note, if you accidentally lock yourself out of the server using the firewall, so if you load a rule set that does not allow SSH through, you can recover that. It's not the kiss of death necessarily. What you have to do is go in via the console, the VNC console that your cloud hosting provider provides, sign in here, and then you can disable the firewall or tweak the rules and then SSH back in again. So as long as you have access to the VNC console here, the one you use to install the operating system to begin with, you can recover from accidentally kicking yourself out on port 22. But easiest way to avoid this is just to be careful to ensure that you're always allowing port 22 through the firewall before you load a new set of rules. And that's the firewall. So again, I just want to reiterate, I am not an expert at this. I'm just an idiot who's read through the documentation a little bit. So prior to deploying something like this on a server that really matters, I would advise you to talk to somebody who specializes in PF and verify that you're not doing something stupid, because it's entirely possible that I am doing something stupid here. But this basic configuration seems to work pretty well. I've never had any issues with it, and it's very close to what I actually use. My setup's a little bit more complicated, but the basic concepts are the same. And this pretty much brings a close to at least this chapter in this web hosting series. We now have a web server hosting a website over HTTPS with a firewall. There's more to the story than just this, but I'm going to call that an end to this particular chapter. So future topics that I will release videos on, but they're not going to come up in this first batch, we'll take a look at some tweaks that we can make to OpenBSD, to our server here, to make it a little bit easier to work with, because obviously OpenBSD is a little bit different than Linux, and there's some stuff that it does differently. So we can configure a few things to make that a little bit more familiar. Additionally, we'll need to take a look at headers. One thing that you may want your website to do is have HTTP headers, which are used for a variety of things, especially security things. HTTPD, the server, does not directly support headers. The way that you're supposed to do it is using a slightly different service called RelayD. And so there will be most likely a video in the future about setting up RelayD to attach headers to your web server responses. And we can also take a look at hosting multiple websites on the same server and a variety of other things like that. So this is not the end of this entire series, but this is the end of this particular chapter. Feel free to share any comments, thoughts, suggestions, things like that in the comments section down below. Also, if you have a better idea for how to set up the firewall, by all means share it, and we can take a look at getting this firewall working a little bit better than the kind of blunt instrument that it is right now. In any case, I hope that you found this video interesting, and I'll see you in the next one, whichever one that may be.